Functions are fundamental building blocks in JavaScript applications. Understanding how to handle parameters is essential for writing code that is clean, flexible, and easy to maintain. In this example, we define a function called greetUser that takes two parameters, name and greeting. The function uses these parameters to construct a greeting message using template literals and then returns the message. When we call the function with the arguments Alice and hello, the function returns the string hello Alice. Default parameters allow you to assign fallback values to function parameters. These default values are used when an argument is not provided or if the passed argument is explicitly undefined. In the createUser function, the age parameter defaults to 25 and the role parameter defaults to user. When we call createUser with only the name Alice, the function uses the default values for age and role and returns an object with the name Alice, age 25, and role user. This is very helpful in setting up some basic or default values for our functions. REST parameters allow a function to accept an indefinite number of arguments as an array, providing a cleaner approach compared to the arguments object. The REST parameter is denoted by 3 dots followed by the parameter name, such as numbers. Inside the function, numbers becomes an array containing all the arguments passed to the function. In this example, the sum function uses the reduce method to calculate the sum of all numbers passed to it. The function can be called with any number of numerical arguments, as shown. The first call sums 1, 2, and 3, resulting in 6. The second call sums 10, 20, 30, and 40, resulting in 100. REST parameters provide a more flexible and readable alternative to the older arguments object. The arguments object is an array-like object available inside functions. It contains all the arguments passed to the function, regardless of how many parameters were declared in the function definition. However, it's important to note that arguments is not a true array. It is an array-like object, which lacks some array methods. Additionally, arrow functions do not have their own arguments object. It is recommended to use the REST parameter rather than the arguments object for modern JavaScript code, due to its limitations. In this example, the printargs function logs the arguments object to the console. When the function is called with a 1 and true as arguments, it logs the array-like object with these values at indices 0, 1, and 2 with the length 3. Destructuring allows you to extract values from objects and arrays directly in the function parameters, resulting in more concise and expressive code. Instead of accessing object properties using dot notation within a function, you can destructure them in the parameter list. The displayUser function takes an object as a parameter and destructures it to extract the name, age, and role. If the role is not passed, it will take up the default value of user. When we call the displayUser function with the user object containing the properties name and age, it extracts the values and returns a string with the name, age, and the default value of the role. Destructuring greatly simplifies the code and makes it more readable. Destructuring can handle nested objects and arrays, allowing you to extract deeply nested values with cleaner syntax. The function processor takes an object as parameter and destructures to extract the name, age, and city from the nested details object, and the main skill from the skills array. The function then returns a string that includes the user's name, their city, and their main skill. This capability to destructure nested structures makes code more readable and easier to work with. Parameter validation ensures that function inputs meet the expected criteria, improving code reliability and providing clear error messages. It is crucial to validate parameters to prevent unexpected behavior. In this example, the createUser function checks if the name is a string, if the age is within a valid range, and if the email is a proper format. If any of these conditions fail, a corresponding error is thrown. This helps in catching any input errors early. Optional parameters allow functions to work with varying numbers of arguments while maintaining a default behavior. They help create flexible APIs by not requiring every single parameter to be passed while calling a function. In this example, the configureApp function has 4 parameters: port, environment, timeout, and debug. All parameters are optional and also have a default value. Additionally, nullish coalescing is used to check if a value is either null or undefined. If the debug parameter is either null or undefined, it defaults to false. The function can be called with or without parameters and returns an object with the appropriate values. Various approaches exist, including setting defaults, nullish coalescing, and object spreads. JavaScript does not support function overloading like some other languages do. However, we can simulate function overloading by inspecting the number and type of the arguments passed to a function. The calculateArea function takes a variable number of arguments. If one argument is provided and it is a number, the function calculates the area of a square. If 2 numbers are provided, it calculates the area of a rectangle, and if an object with a radius property is passed, it calculates the area of the circle. This approach enables a function to perform different actions based on the given parameters. Advanced overloading patterns can create very flexible APIs. In this example, we define a string builder class with an append method that simulates function overloading. The append method can take any number of arguments of type string, number, or array. Based on the type of argument, a specific action is performed. This mapping allows for dynamic handling of various parameter types, which can be very helpful in setting up APIs that are easy to use. The type is inspected and then the corresponding method is called. This way, a single method can perform a different action based on the type of the parameter. When working with functions, it is important to follow some best practices to make the code more readable and maintainable. One key practice is to limit the number of parameters a function takes to 3 or fewer. If you need to pass more parameters, use an options object. The code shows an example where we use an object to pass the parameters. It makes it much easier to call a function and see what all parameters are passed. Second, use descriptive names to indicate the purpose of each parameter. Avoid abbreviations unless they are very common, and lastly, always validate parameters at the beginning of a function to fail fast and give clear error messages. There are some more best practices that are essential to follow. Never modify a parameter directly. Instead, create a copy and make modifications on the copy. This preserves immutability and makes debugging easier. Also, maintain type consistency throughout the application. Always use the same type for a parameter and properly document it. Finally, always provide default values for optional parameters and document the reason for using the default value. These best practices will help make your application easier to maintain and less error-prone. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.